Okay, as promised yesterday, I'll do a quick review of this little, what I call a critter checker. Its technical name is an LCR-T4, which stands for inductor, capacitance, resistor, and then -T, I guess, is transistor. But it'll also do diodes and JFETs. Runs off a 9-volt bulb. Battery costs under $20. Now you have to watch. I buy my stuff off of Amazon. That's my first choice. AliExpress and then eBay. And one of the things that you got to do is shop at all three and find the best deal. Find a highly rated vendor. How many stars they get, what their rating is on eBay, etc., shipping charges. It's just like shopping anywhere else. Okay, now let's do the following. Let's start with the transistor. Now I bought 1,000 2N3904s, and I told you that I made the selection based on one, price, number two was the rating of the vendor, and the fact that he had 5 million transistors, and I don't think any of them will be bad. Now, out of 1,000, there may be one or two DOAs, dead on arrival things, that just the manufacturing process is not perfect. So I check everything, just not out of paranoia, but just out of concern or care. Here's what 1,000 of them looks like. I buy my little containers at the Dollar Tree for $1.29, and I bought these anti-static bags off of Amazon, 1,000 of them or whatever, and they're cheap, just a cent or two a piece. Put transistors, FETs and ICs in these, and I mark them. But this is in these are all 3904s, so that's what I label on the end. So let's just take one. Here I took one out, and let's measure it. What you do is, this is a zero insertion force socket. Lever up opens up the gates for the pins. This is pin 1, 2, and 3, and then 1 continues over here because some objects, some inductors and what have you, diodes maybe have long distance, so get it covered. For a transistor, I'm going to put it in the first 3 positions, lock it down, push the button, and you're ready to go. And this is the 3904. Now remember from the data sheet yesterday, we said that the H/FE, that's the DC gain, was going to be starting at 250, I think nominal 270. I'm testing my memory here. And there's no upper limit. When this number is down on the low end of the scale, this thing's probably got a high F/T, and we're going to measure it. Now, because I got this one, I'm going to I put stuff in coin envelopes, so I'll show you that in a minute. Let me mark it as 2N3904 F/T test. What is today? Oops, September, I don't know what it is, 18th, 16th? I don't know what day it is, 16th. All right. And take the transistor out. Oh, let me do that. This is fun. Whoops. See, sometimes this thing is digital. Okay, it's 286. Okay, so let's put that down there. H/FE equal 286. put it in here. When I get my Epson tester finished, we'll test that. Now, this thing tests diodes. Now, in today's market, high intensity LEDs all come in clear plastic and got 2 leads. We know from years of use that the long lead is the anode. Now the thing has a flat side. This is round and this is flat, so I know which way it is, but just stick it in here, and what happens is this thing is going to pulse this thing to find out what kind of a device it is, and this thing will flash. So if you don't know what color it is, put it in your tester and go, it's green. And the voltage drop across it, the forward voltage drop across it is 2.91. So if I put this in a circuit, I know the voltage drop across it at I think 10 mils or whatever is going to be 2.91, so I can figure that in Ohm's law and figure out current, voltage drops and everything. A diode does have, if you put an AC voltage across it, it does have some capacitance, 11 picofarads. So a nice use there. The brighter colors, blue, green, and white, are all going to have high voltage drops across them. It has to do with solid state physics. Let's take a red one. I expect the voltage drop across it to be low. Also, if you've never used one of these, and I'm just speeding through here, it'll tell you which way is oriented, so if you have one that somebody cut the leads on or whatever, you can figure it out again. Now, this is red. It's going to have a 1.87 volts, so it's lower than the other colors, and it's got a lower capacitance. Not that I need the capacitance. I usually operate those at DC. Now, if you have a lab or you're going to build a lab, you're going to need some parts. And I got a box of 1/8 watt carbon resistors, 5%. I think it was $20 for 3,000 or whatever. They're, penny a piece. Now, these things are marked. So we're just going to take one. Let's take, I've been using these so you can see where I cut them loose. Let me take this is a 10K. Let me pull it off here. This is called an ammo situation. It looks like a 50 cal load going into a C-140 gunship or whatever. This is not, I haven't done it yet. I did it from a 1/4 watts, but I use the same coin envelopes, stick individual values in each envelope, mark it as 10K, 1/8 watt, carbon, because I have both carbon and metal, thin metal film resistors. Now, what did I say? I've got a 10K here. Let's check, see how good this is on. This is not science here. This is not rocket science. We're not trying to get the value down here to 1/10 of an ohm or whatever. Now you have to be careful here. Pin 1 is here and all these points, and see here we've got all these are 1s. That's just for a case like this where you've got a distance that's more than 5 millimeters. So this is 10K, right? Let's see how. Now remember, this is a analog to digital device, so it's got resolution issues, etc. 10K, and this comes out 9.7. We know it's in the ballpark. If I wanted to, let's see if I can do this without. See if I got you in here. This is an old digital multiplier. Let's put it in the ohms mode. It's auto ranging, so I don't have to select where I think it is. And let's see if I can measure it. Whoop, clumsy. 9.76. What did my I didn't pay attention to what a 9.76, and I forgot what I got here. Oh, that's because I stuck it in two ones, okay. That happens a lot. 9.76 versus 9.73. That's pretty good. That's pretty good. Not bad. Sometimes you'll be working with an eighth watt carbon resistor. To read the color code, you got to get a 20 power loop or stick it in here. $456. So this is a 470 ohm resistor, and it is yellow, purple, brown. Did I leave anything out? Oh yes, I've got some molded inductors. Now they come in a pack, you know, 15, 20 values, whatever, and these are 1 watt. And they're marked at 2.2 microhenries. So let's see if this critter will measure 2.2 microhenries. Now this thing has, I don't know what frequency it tests the impedance at, but let's see. It's got such a low resistance that the resistance overrides the inductance. So it's 0.37 ohms, which means it's got a fairly good Q value. Here's an expensive device. This is an LC200, and I made a little printed circuit board to put things on here. Let's turn it on. Okay, is this going to be a high? Let's do a high L 2.2. To calibrate it, I need to short it, so it's not calibrated. So ballpark. I'll use a little socket thing here. Oh, high thinks millihenries. Okay, let's take this off. Okay, it says that it's in the range of 2.8. I need to calibrate it, but it's in the ballpark. So this is another instrument that you need, but I'm going to get you to spend $70 instead of $40. So, quick review of another piece of test equipment that I use a lot, and it's just quick and dirty. If I want precise values, I'm going to do something else. Okay, that's it. Talk to you later.